Okay, today's topic is on motion. Okay, every object that we see around us, it is either in motion or it is in rest. Okay, suppose house, tree, these objects do not move along with time, so these objects are said to be in rest. But suppose a train that is moving or a boy who's running, they are changing their position along with time, so they are in motion. So now the definition of motion would be like this: an object is said to be in a state of motion if its position changes with time with respect to its surrounding. So suppose a train that is changing its position along with time or moving. Okay, so the train is in motion. A car that is changing its position with time, so car is in also in motion. Even our earth changing position along with the time and moving around the sun, so earth is in also in motion. But resting objects like the house or the trees, they do not change their position in accordance with the time, so that means they are in rest. An object is said to be at rest when its position does not change with time with respect to its surrounding. Okay, now the rest and motion both are relative terms. Okay, now let me explain this one. What the relative terms means: suppose you are sitting inside a train, so you are moving along with the train, but the train's walls or the seats, they are in resting position, so they are also moving along with you. So the walls or the seats of the train are in rest in respect of you, but as a whole the train is moving in respect to its surrounding. Suppose all the railway tracks or all the other trees that are outside of the train, in respect to that the train is moving, but in respect to you, your seat or the walls of the train or whatever that is inside the train, those things are also moving along with the train. So in respect to yourself or all that objects, those are in resting state. Now there are different types of motion also. See at page number 29, types of motion is given. Suppose translatory motion, rotatory motion, oscillatory motion, multiple or complex motion, periodic motion, non-periodic motion. Okay, so now starting with the translatory motion. What is the translatory motion? In translatory motion, the object as a whole moves. Each part of the object moves the same distance. Okay, now the translatory motion is divided into rectilinear motion, curvilinear motion and circular motion. So whenever as a whole the object moves, then only it is translatory motion. But in case of rectilinear motion, the object moves in a straight path. Okay, the object will move in a straight path. Suppose a boy running straight on road or a car that is running straight on road. These are example of a rectilinear motion. They are moving in a straight line. Okay, they are not bending or they are not curving to the left direction or to the right direction. Okay, they are just moving straight. That's why it is rectilinear motion. Next is curvilinear motion. So in case of curvilinear motion, what the name suggests, curvy and linear, so that means they are moving in a curved path. An object moves along a curved path, then only it is a curvilinear motion. Suppose the motion of a cyclist on a curved path. At page number 30, there is a picture of a cyclist is given here. See, the cyclist is moving in a curved path. Also, whenever motion of a cricket bat like this happens, the ball moves in a curved path. So these are example of curvilinear motion. But in rectilinear motion, in a straight line, the object as a whole moves. Suppose here if a stone falls from high above, it falls on a straight line. So this is example of a rectilinear motion. Next comes the circular motion. It is also a part of translatory motion. What happens in circular motion, that object moves along a circular path. Okay, object moves along a circular path. Okay, suppose motion of moon around earth or motion of earth around the sun. These are example of circular motion. Next we come to rotatory motion, and it is different from translatory motion. Okay, so in translatory motion the object as a whole was moving, but in case of rotatory motion only around an axis or a point. Okay, based on an axis or a point, around that the object will spin. Okay, see the pictures of page number 31. A merry-go-round, okay, a merry-go-round or a top, both have a axis at the middle of it, and around that axis they are spinning. If an object moves about a fixed axis or a fixed point without changing its position as a whole, okay, this is the main difference between that translatory motion and rotatory motion. In case of rotatory motion, they are not changing their position as a whole and they are moving around an axis. So here in case of this top, this part is the axis of that top. Okay, in case of merry-go-round, there is a steel beam in the middle and around it the merry-go-round is moving. Okay, so these are their axis, and around these axis they are moving, and axes are in a fixed position and part of the object is moving. So this is the rotatory motion. Next we are moving into oscillatory motion. So if an object moves to and fro about its mean position, then the object is said to be in oscillatory motion. Okay, suppose here is a swing, example of a swing at page number 32. Example of a swing is given, example of a pendulum clock is given. So this is the pendulum and it is in the mean position, that means in the middle position, and the pendulum moves towards the left side and towards the right side at uniform speed. Okay, so this is the to and fro motion, and it stops for a very short amount of time in the middle or at the mean position. So from the mean position it moves towards left and towards right, that is the to and fro motion. It is also called oscillatory motion. Also in case of this swing, this will be the mean position, and from this position towards right and towards left the swing moves. So it is also an example of oscillatory motion. Next is vibratory motion. Okay, so very fast oscillations are called vibration. So whenever oscillatory motions happens at a very fast rate or a very high rate, then it can be called a vibratory motion. Also in case of vibratory motion, the object as a whole does not move, only a part of the object vibrates. Okay, only a part of the object moves to and fro about its mean position, but as a whole the object remains at rest. Suppose you are trying to play a guitar, then the strings of the guitar, whenever you touch it with your fingers, then they will start to vibrate and produce sound. So as a whole the guitar is not moving, only the string is vibrating at a very fast rate. So to and fro motion is happening in the string and vibratory motion is happening. Also in case of tabla or drum, whenever those are played, then they show the vibratory motion and produces sound. Next is multiple motion or complex motion. Okay, so the definition of multiple motion is when an object simultaneously shows a combination of two or more types of motion, then the combination of these motions are together called multiple motion or complex motion. Suppose in page number 33, here is a picture of a car given. So it is showing two types of motion at the same time. The wheels of the car, they are showing the rotatory motion. Okay, so the cars have axle or axis in the middle, and around that the wheel is moving. Also the car is showing translatory motion because it is moving in a straight line. So here two of the motions are happening at the same time. So as a whole, the car is showing a complex motion or multiple motion. Now in case of this drill, it is showing rotatory motion because the nozzle of the drill is rotating, and it is also showing translatory motion whenever it is going through this wood. Okay, so that means it is moving in a straight path. Two of the motion are happening at the same time in case of this drill, so it is showing multiple motion or complex motion. The last one is random motion. Okay, so random motion of an object can be seen if their path is not specific. Okay, when an object has no specific path and frequently changes their direction or motion, okay, so it is called random motion. Suppose a butterfly that is flying, or a mosquito that is flying, even flying a kite, okay, so they move at a random direction or not in a specific direction, so that's why it is called random motion. Next is periodic and non-periodic motion. Sometimes a motion repeats itself again and again after a fixed interval of time. So only if in a fixed interval of time that motion is getting repeated, then it is periodic motion. Suppose the earth is moving around the sun, or the moon that is moving around the earth. So these are example of periodic motion because every time this is happening in a specific time. Also our heartbeat, that can be called a periodic motion as well. Next is non-periodic motion. A motion which does not repeat itself at regular interval of time is said to be in non-periodic motion. Okay, suppose a man walking in the park, or an athlete who's running, a cricket ball that is hitting on the ground. Okay, these are example of non-periodic motion because every time they are not happening at same speed or not happening in the same way. Now try to solve this checkpoint 1's questions in your copy. Thank you.